Yeah, my name's Luke Waltz. I'm a PhD student in the Food, Ag, and Biological Engineering department. I'm going to talk about a project we've done called Drones and Data in Agriculture, where we collected a lot of data on the Battle for the Belt sites in conjunction with Laura and Osler and Taylor. And I just want to share with you what we've learned in that. It was funded by the Nationwide AgTech Innovation Hub. So prior to the AgTech Innovation Hub, I knew Nationwide was a large insurance company headquartered in Columbus, but I didn't realize they had such agricultural roots, and I've come to find out, they started in 1926 as being started by the Ohio Farm Bureau. So they provided some initial funding, and about a year and a half ago announced at the Farm Science Review. And our project was one of five to be in the first cohort to be funded last year. And so the College of Agriculture at Ohio State just put out a nice overview video of a couple minutes that I'll share right now to give you a sense of the project, and then we'll go through some more details. How about now? Do you get sound?
Yep, we're good. We can hear it.
Great.
My name is Luke Waltz. I'm a second-year PhD student in the Department of Food, Agricultural, and Biological Engineering. A lot of people try to use AI in agriculture. It seems like they're working with maybe smallish data sets that don't have a lot of diversity to them. I don't think we've seen a really large multimodal data set that's put together. So part of, I think, what's valuable about it is just the effort we put in to get all the different types of data combined that are annotated with both position and time. Diversity in our data set means that, just like I have sight and smell and touch and hearing helps me perceive my environment around me, the multiple modes of data helps us understand what's happening with the corn and soybeans. So the drone data overhead gives you one perspective. A smartphone, while it's still an image, gives you another perspective close in. And the soil data that you're looking at in the ground also gives you an additional perspective. So those multiple modes help you get a better perspective on what's happening to the corn and the soybeans. We've seen some early results with some of our time-lapse imagery where we calculated the uniformity of emergence of corn and soybeans. So corn in particular there's a correlation between how uniformly it emerges and the final yield. We've also seen the correlation between our soil volumetric water sensing and matrix potential relative to the precipitation across the three sites. Our goal here is to be able to really look at how can we be more accurate at yield estimation. Another one was growth stage. So could we classify growth stage of corn and soybeans, which is really important for both fertilization as well as weed pressure or herbicide or fungicide application. The data set is complete. The remainder of the project will be really trying to build those algorithms, tune them, figure out which hyperparameters work best in the model so that we can prove that we can estimate those things with some accuracy that would be valuable for a farmer. Our aspiration was to really provide science that can help the farmer be more precise. It's a really challenging problem in agriculture because there's so many variables that affect yield, right, from year to year, right, and from field to field. And so the research that we're doing this year is really helping to get at that, how to help them be more precise in their inputs.
Great. So I'm going to go into some more detail on things we've learned, but if you see, I put up just a Slido.com poll, and Ryan's going to put a link in the chat as well. I'm just curious on what you all in the audience today are most optimistic about in terms of technology for improving your farming operations. So I put a collection of things in here that I thought might be on your list, like drones, spray drones or scouting, or using drones for cover crop seeding. Some of the newer ground-based selective spraying like John Deere See & Spray or Bilberry, variable rate fertilizer application, autonomous tractors, improved ways to manage what's on your farm, autonomous tractors, or something else. Maybe there's something on your list that I don't have on my list. So if you just take a minute and be curious to hear what people are excited about in the audience today. So it looks like drones are the early leader here. With the selective spraying and variable rate looks like they're number 2 and 3. Looks like drones are the clear leader so far. It looks like they're probably have an insurmountable lead, it looks like. few people have talked about autonomous tractors, and there's a few something else's, which would be great to hear maybe later on what the something else was. So I'll keep going. I'll leave the poll open if you all want to, keep on going in and updating it. Maybe we can at the end come back and see what the final poll results are. But I want to talk about how the Drones and Data in Agriculture project that was funded by Nationwide and Farm Bureau with Ohio State related to the battle for the belt. So in just this simple graphic, you've heard from Osler and Laura and Taylor, all the great work they did. There was a plot design and field layout that, Taylor and I would cross paths many times over the summer with her weekly field visits and my data collection. And there's a lot of work at harvest to not just get the yield, but also get, aspects of the components that contributed to yield. And so that was certainly led by the, horticulture and crop science people at Ohio State. And with our drones and data in agriculture, we had both people in computer science and people, myself in food, ag, and biological engineering that really wanted to say, could we take all the infrastructure and logistics that Laura and Osler and Taylor had done, and could we add additional technology and data collection to it to get greater insights for their project, but also to say, could we use some of these for artificial intelligence use cases in agriculture? And so just to talk a little bit about, my perspective on AI applications in agriculture, it's a lot about the data, and it's a lot about really good use cases. And so in here, I show there's what we call ground truth data, which is ground truth data is very expensive to collect. So, with Taylor driving all over the state of Ohio this year, that was very expensive, right? To get there to walk through every plot and get growth stage classification. We also included a lot of infield sensors and drones as well. And so this infield sensors for us were also ground truth measurements that we put them in research plots, but we realized that they would not typically be viable for production agriculture. And then we have input training data, which is a lot of our drone flights. While they're not cheap, they're more and more people are using them for crop scouting. And weather data is freely available. And we also did some work on time-lapse imagery. And then thirdly, you need to have use cases, right? What are some things that would be valuable to understand better? And so when you combine those three things, you can put together AI models. And over the last 10 years, a type of AI called neural networks has become very effective and very, very prominent. And then even the last, say, 3 to 4 years, a type of neural network called a transformer, which is, if any of you have used ChatGPT, that uses a type of neural network called a transformer. And so we're trying to use these latest and greatest models that are coming out of the computer science and artificial intelligence community to say, how can we use them in agriculture? And so with that, if you've built an AI model from the data, you can now give it new input data. And the term the computer scientist uses inference, which is you basically pass the new input data through a model, and then you get important values like yield estimation or growth stages for crop phenotype, or you can estimate soil moisture, or you saw a lot this morning about plant disease, right? So if you have a large labeled data set, you can start to predict from imagery, what's the incidence, what's the severity of certain types of diseases. So this was kind of our mindset going in to say, could we use the battle for the belt sites to do some things around artificial intelligence that would be valuable in agriculture? So I want to share kind of 4 things we've been working on. There's a little more than this we've been doing, but we thought this would be valuable for this audience, which is, our question was, how do we use straight data from drones and infield sensors, combine it with artificial intelligence to benefit farmers? And so these are 4 areas we looked at: emergence, phenotyping, soil moisture, and kernel weight. So the first one's emergence. I think many of you probably heard of the flag test, particularly in corn. You would like all the corn plants to come out of the ground soon, like ideally within the same 12 hours. And on the picture on the left is shown an example of a flag test where you've marked off, maybe 17.5 feet, which would be 1/1000th of an acre, or maybe it's longer. And you would go out there every 12 hours from the time you saw the first plant emerge over the next 3, 4, 5 days. I've not met anybody yet that's actually done this test because it's so labor intensive, right? And then on the right, you see this was precision planting material where they, showed, the corn ears that emerged within the first 12 hours. You can see are very full in the very top, and then the ones that emerged 48 plus hours later in the very bottom have, a 98% yield reduction. So our question was, could we take something that's very labor intensive, but also seems to be pretty valuable, and could we measure that with time-lapse cameras? And so we we had some cameras. We actually had some 10-year-old trail cameras that were in the ag engineering building that weren't being put to good use. So we were able to use those. We had some Amazon light poles, some scrap lumber, and zip ties. So in true ag engineering fashion, we put some of these out in the battle for the belt sites. And I'm going to show a time-lapse video. The bottom left picture here on my screen shows, you'll see a date stamp, and it's going to cycle through. It took images every 15 minutes over several days. And we've been doing some computer vision techniques to see if we can detect and actually create a curve of emergence versus time. So you see, as soon as the algorithm finds a plant emerge, you'll see the red circle. In the bottom right, you'll see the time passing through. This was from a planting date that was emerging around May 20th of last year. And still not as good as we would like, but it's starting to get better, where we're starting to say we can pass a series of 100 images into it and be able to now create this curve of emergence versus time. And so we know that the conditions you plant into can affect your the uniformity of your emergence, and also how your planters set up. So there's a lot of advanced technology in planters to try to get that corn to emerge as uniformly as possible. So that's one thing we've been working on and starting to see some nice results there. The second is phenotyping. So you saw in the video some shots of the drone. This was a Wingtra drone. This is really nice for some of the work we're doing. It's a vertical takeoff and landing, which means that it's sitting upright on its tail in that left-hand picture. And there's a tablet you use to control it, and it basically takes off, then goes horizontal and flies like a fixed wing, which means it's very energy efficient, and you can typically get hundreds of acres on a single flight. We had two different cameras we were able to use. One was a high resolution red, green, blue optical imagery that was a Sony camera. And then there was also a multispectral camera that had 6 different bands in it that you can use to measure things like NDVI, which is a crop vegetation index. And so this is just an overhead view of the 3 sites, Northwest on the left, Western in the center, and Worcester on the right. So as this Wingtra collects the images, it collects hundreds of images for each site. And then there's some software you can use to stitch together. And then there's software you can use with shape files that you can actually create the corn and the soybean plots. So you see in these images, the blue plots are soybeans and the red plots are corn. So each one is 4 rows of corn and either 7 or 8 rows of soybeans, typically 30 feet or longer in each plot. So we've been using this data to be able to see if we can detect growth stage. And so this is an example of some of the work that we've been doing. Another fellow grad student in our lab has been doing with growth stage. So the x-axis shows the labels that Taylor did. So when Taylor would walk through every plot every week and come up with a growth stage. And then the y-axis shows how good is our algorithm doing with using what's called a vision transformer to detect it. So 0 would be perfect. If it's minus or plus, it means it got the growth stage wrong in one direction or the other. And what you see, it's up to V8, it's within 1 or 2 typically. And then if you see it R1 to R5, it's maybe within 2 or 3. And then that later vegetative growth stages, it's not quite as good as we want it to be, but it's kind of where we're at the moment. Another thing we were able to see with some of the imagery was raccoon damage. So I'm not, I hear a lot of bantering back and forth between Laura and Osler, and I'm not sure if Laura might have had a hand in the raccoon damage, but we're able to see from the drone a lot of things going on inside the field. Thirdly, we were looking at soil moisture. So, we installed sensors in all 3 fields at multiple locations, and we were asking ourselves, could we detect soil moisture? So, and also how might it vary across different soil textures and organic matter? So, Worcester, Western, and Northwest all have different amounts of soil, silt and clay in them, and also different levels of organic matter. So we were curious about, would it be different across those? And also, could it be useful for understanding nitrogen mineralization? So we used equipment from Meter. This is an example of the Teros 12, which got installed we installed at 2 depths at 12 inches and 24 inches. And then on the bottom right, you see a chart that we've been able to put together where the blue bars are the precipitation. This is at Northwest. And then the green bar is our measured from the ground truth sensor moisture in the soil. And the red is a a type of neural network we use to try to predict the soil moisture. So you can see it's not perfect, and we're still working to make it better, but it's for most of the growing season, it does a decent job at trying to approximate the moisture that's in the soil. And then last is kernel weight. Our question was, could we use weather data to predict kernel weight of corn? So in one of Taylor's YouTube videos she put on this summer, she talked about, how do you estimate corn when you get to the later part of the season, and you count the rows around and rows long and the number of ears in a certain section of the field, and then you use I think she called it a fudge factor for how many kernels per bushel. And so our wonderment was, could we, using the weather, could we come up with a better idea of what we would expect in terms of kernels per bushel? And so on the right-hand side, you can see where we used maybe I'll start with the bottom left. One of the values of the Battle for the Belt is with 5 different planting dates, you really get 5 different weather patterns for each planting date. So in a single season, you can actually get a lot of diversity and a lot of variability in the data set. And so the graphic there's just trying to show that, grainfall happens at a different time at each planting date, which means it experiences different temperature levels and different precipitation levels. And so we use that differences to say, could we train a model to predict kernel weight? And what you see on the right is from our test set. So we trained the data on 64 plots at Northwest, and then we tested on these 16, and we saw a pretty nice correlation from kernel weight. And the importance of kernel weight is, as you see the text in there, if you're at 70,000 versus 90,000 kernels per bushel, that could be the difference between 225 bushels an acre and 175 bushels an acre. So it's a big deal, and we thought, it could be a valuable thing to be able to have a better idea of how much you expect your harvest to be when you put the combine through the field. And so we've collected a lot of data across the Battle for the Belt, and one thing we're exploring right now, and this is a concept, is how can we take these vast amounts of data, soil moisture data, soil electrical connectivity, drone data, time-lapse imagery, and how can we find ways to maybe combine it in ways that might be valuable for farmers or for researchers? So this is just one example, and we're kind of exploring how can we put the data together in ways that might be unique and novel, and something that's maybe not being done with any of the commercial software providers. So in conclusion, we've also been looking at the things we've been collecting from 2023, and we think we could be valuable to take it and orient it towards improved nitrogen recommendations, which we know can be challenging to get right season to season. And your feedback would be really valuable to us. We will be putting out a survey in the next few months regarding innovation and technology in agriculture. We would love to hear your responses to it. We would like to get your feedback on anything you saw in this presentation. So, we're working with data. We have some ideas of what we think might be valuable, but we would love to hear your feedback. If it's all right or all wrong or somewhere in between, I think that would really be valuable to us as a research team to make sure we're orienting our efforts to things that would matter to you. And lastly, if you're interested around nitrogen use efficiency, that's an area that as we're submitting our letter of intent for this year's nationwide project, we're taking our efforts and want to focus on nitrogen. So if that's an area of interest to you as well, we would love to talk with you about that. So lastly, there's my contact information again, if you want to email me. And we've also put up a website, go.osu.edu/cropfusion, where you can, see the collection of videos and other work that we're doing, and the various people that are involved in the project. So that's what I've got. Does anybody have any questions for me?